Oh, they can turn it on. It's trying to trick you.
I would like to start by acknowledging the custodian for the land we're meeting today, and acknowledge elders, past, present, and emerging. And I'd also like to welcome Indigenous Australians. I would also really like to thank Marnie for bringing together such an amazing and diverse group of people to talk about a really subject. And particularly to thank you for giving me the opportunity to talk about this process. We're in the process of developing this national light pollution guidelines for marine turtles, seabirds, and migratory shorebirds. And it's really exciting to be able to talk to you guys at this point in the process, because I think that everyone in the room has something that they can contribute to developing these guidelines. So I'm very grateful for being here. So this project is actually a collaborative project between the Commonwealth Department of the Environment and Energy, which I'm a member, and also I have Fiona Martlett here, who's also my team. And we are developing this project in collaboration with Western Australian Government, and we've been fortunate enough to be able to contract Pendoli Environmental, who have built a fantastic team to help us with the development of the guidelines. So that team consists of Kelly Pendoli, who is our keynote speaker this afternoon, Adam Carey, who was our keynote speaker yesterday afternoon. We've also got Catherine down here as well. So it's a really strong team that brings the diversity and expertise to developing these guidelines. So I wanted to have what the guidelines aim to be. And I'll start off with this tricky picture of Vanessa at the beach in Florida, because it really exemplifies perfectly the first light and grey light. So the other thing that I want to say is these guidelines because we have very strong evidence that light is impacting on these taxa. We've also been a little primarily because our team has a management come back. But I want to talk about marine turtles. These guys are probably on the first children of the light impacts on outside wildlife. The marine turtles are reptiles. They spend they spend the vast majority of their life out in the ocean. They come ashore for one very important purpose, and that is to lay eggs and to reproduce. So we've known for a very long time that light can disorient adult female nesting turtles when they're trying to find their way up and down the beach. We also know that those nesting females don't particularly like nesting on lit beaches. They prefer to find those nice dark beaches. But they will still nest on lit beaches, which can be unfortunate for the little hatchlings that if they emerge after they've incubated in the sand for approximately 2 months. If they come so just imagine that you're a tiny little hatchling. You're there with all your brothers and sisters, and there's probably about 100 of you that are coming out of a nest. You wait until darkness. And so that the sun sets, there's a temperature cue, the light, the sand around you decreases, and you all come flooding out of the nest at the same time. And this is primarily to avoid predation, because the hatchling turtle is about this big, and they're just a fantastic bite size for everybody out there. So the birds, the fish, you name it, everybody wants to eat a hatchling. So they come out en masse to try and avoid predation, but they also come out under cover of darkness. So how is this turtle going to find the ocean if it's dark? And the answer is that they use light cues. So if you imagine a pristine beach, these turtles are going to come out, they're going to have a dark sand dune behind them, they're going to have some vegetation, and they're going to have stars and moon reflecting on the ocean. So what they're cueing into is the lowest light horizon. So it's not actually that they're attracted to light per se, it's that they're using cues of light and orientation to find that lowest light horizon. Having said that, we do know that if you have high intensity light, they have no hope of finding that low lit horizon, and they will make a beeline straight for the light. And we also know that unfortunately they're particularly attracted to that blue end of the spectrum. And for a while there was an idea that turtle-friendly lights might be okay if they're in the amber end of the spectrum, but unfortunately we demonstrated here in Australia that is not the case. They're attracted to amber lights, especially if they're at high intensity. And it's not only just getting across the beach from their nest. We've also recently discovered that once the hatchlings get into the water, they'll actually start swimming out into the ocean, making their way out into the safer, deeper water. But if they see lights back on land, they will actually turn around and come back towards those lights. And of course, as you can imagine, that first sort of 500 metres or so of water is where all those big fish are, and where those birds are all waiting just to pick them off and eat them. So this is a huge problem. The longer they spend in that close environment, the worse it is for them. And in fact, there was a really neat study, or a couple of studies that have recently been done on both green and flatback turtles, where, which Kelly was involved in as well, where they actually put an acoustic transmitter on the little hatchlings. As you can see on that top picture up there, the acoustic transmitter is attached to the caravan. They release them from the beach, you have this dot here, into an acoustic array. So all those little white dots that you can see, they're acoustic receivers that are basically listening for where the hatchlings went. And you can see in the left-hand panel there that when under no light conditions, so ambient light conditions, the hatchlings all kind of make their way out, and this is type dependent, I'm not going into detail there, but they all make their way out fairly quickly, directly through that array. Unfortunately, if you add a light to this scenario, and hang out under that light. And unfortunately, that also can end up being a fish attracting device because the turtles are spending longer in that area and they're more likely to be taken out by the fish. And as I alluded to before, there is actually no such thing as a turtle-friendly light. So, and unfortunately, there is on the market at the moment that are being sold. All right, so I'd like to thank Andre for giving an example, a fantastic introduction to the impacts of lights on seabirds. And he talked specifically about the work that he and Aram did on Phillip Island about shearwaters, which demonstrated that shearwaters, well, seabirds in general, are impacted by light, both from the perspective of when they're in flight, running into infrastructure that is lit so they can get disorientated, run into the infrastructure and that causes mortality. But also we have this huge problem with these burrowing birds. So these are seabirds that spend, again, the vast majority of their life out at sea. They come ashore to lay their eggs, and shearwaters are burrowing nesters. So they actually they have their nests underground, and the fledglings come out and they need to take their first flight under cover of darkness. So of course you can imagine that if it never gets dark, they never take their first flight and they end up starving to death. So this is a really big problem for shearwaters. Other seabirds, such as the albatross and petrel, which are found predominantly in the Southern Ocean, there's a problem with the birds interacting with vessels in the Southern Ocean, so especially fisheries. And the agreement of albatross and petrels, or ACAP, has recognised this as a huge problem and has started doing a great education program with fishers to make sure that they light their boats appropriately and that they can handle and manage these birds that are ending up on their vessels. So again, we have really good evidence that light is impacting all seabirds. Now, as I mentioned before, we're being a little bit cheeky and we have tapped into this project consideration for migratory shorebirds. So amazingly from Australia all the way to the Northern Hemisphere. They come back to Australia to forage on the intertidal flats all the way around Australia. And at the moment, our understanding of how light impacts these guys is really unclear. And so we actually, as part of this project, we were able to get some NEST funding, the National Environment Science Program, to try and have a bit of a look to understand this. And what we've discovered so far is that it's actually quite complex. So there are some migratory shorebirds that when they're foraging on the intertidal flats, I should take a step back. these guys are not dying on forages. Their day is dictated by the tide. As the tide goes out, they can go and forage on the intertidal flats and have access to the animals that are living in the sand and mud there. So whether or not it's day or night, they're going to be out there feeding. If you have a great big floodlight, which is lining up that intertidal flat, then those birds that use visual cues for foraging are going to be at a huge advantage, and they might actually do better at having light there. However, those lights might also attract predators. They might be problematic for those species that are not visual foragers, and therefore they're actually finding it harder to actually find their food in competition with the other species. And so what we've kind of come to the conclusion is it's actually quite a complex interaction. And we haven't even started exploring the impact of the light on the invertebrates that are living in the mud and the sand or the intertidal flat. So I think probably when we come to the management of these guys, we have to be a little bit cautious about light and how it's managed. All right, so I've managed to provide you with a bit of background about why. And we've spent the last 2 days talking about the fact that there is lots of light out there. There is a lot of light on the coastline. We're not far from Australia's population. It is on the coastline, and so there is light on the coast where these animals. So we recently developed a recovery plan for marine turtles. One of the key actions that came out of that recovery plan was a need for guidance around the management of light. So hence this project to develop national light pollution guidelines. And I guess their primary purpose is to provide advice to owners, seeking the environment group and LPA, and to be accessible around but it's also our aim that these guidelines will be broader than that, but have broader application. What we hope is that these guidelines will actually provide not only Commonwealth assessment officers, but state, territory, local council, provide advice to everybody who is working in this field. So be it the working groups that you referred to, Carol, that are trying to decide what type of LED and what type of lights to roll out as they bring in the LEDs. We hope that this document will actually provide sufficient information that all areas of government, local council, community groups, and the general public will be able to use, and indeed our lighting designers. And to that end, the aims for these guidelines are primarily to raise awareness, to make people aware that there is wildlife out there that needs to be taken into consideration when thinking about light management. Sea turtles tend to see more like the blue end of the spectrum, whereas seabirds see the red infrared. So when we're thinking about this, like looking at the sky, it's not only the types of light, the guidelines are going to present the best practice set of principles. So essentially, starting from a point of darkness is good. Where do we need to introduce light, and how can we introduce light so that it has the least impact on wildlife? And then how do we do that? Where the guidelines will provide a suite of tools which we can use to undertake that management. So I guess one of the really important things for these guidelines is that they're solidly grounded in evidence. And so they are going to have a very strong background in both light theory, but also animal physiology and behaviour. And the reason for that is that what we hope these light guidelines will do is bridge the gap between two very different disciplines for which we only have a couple of people in Australia who are currently able to bridge those gaps. And to be perfectly honest, I think all of them are probably sitting in this room. So if you think of the number of activities that are going on around our coastline, we need more people that can bridge that gap. And we hope that these guidelines will start to do that. So by talking about light theory, I'm talking about light scattering, what's light glow, how do you measure light, what is light, as well as the animal impacts and the animal physiology that leads to those impacts. And really importantly, one of the things that was brought home to me was the idea about how do we measure light. We as humans tend to think about light as being visual spectrum, so between the 400 and 700 nanometer wavelength. But as I just mentioned, sea turtles can see into the ultraviolet, seabirds can see into the infrared. And if we're not measuring those spectrums, we're not going to be able to understand the impacts of those species. So the National Light Pollution Guidelines are going to take a risk-based approach. So essentially this means I'm rolling out new LEDs or I'm undertaking an action. Is that action going to have outdoor lighting? Is that action going to occur in an area or close to an area where there's important habitat for these species? So it's about stepping through questions that need to be answered in order to establish essentially whether a light management plan is needed and what that light management plan will look like. So what type of mitigation is needed, what type of monitoring is needed. And it makes the light guidelines will make the point that we need not only to monitor the lights, how much light is around, but monitor those biological impacts. And Maya talked about this yesterday when she mentioned that it's not actually the light that we're particularly worried about, it's the impact of that light on whether it's melatonin production or in this case animal behaviour. So that monitoring will have a light component, but it will also have a component of are the hatchlings being going in the wrong direction, and also a forward-looking component. And this is my experience most of that last day, because yesterday afternoon, our last time, so actually, we talked about all the things about LED and there's been a little bit of talk about problems that LED creates, but the fact is that we can apply smart control. We can change it. We can change what they do, but actually much larger toolbox than we previously had to be able to manage light well for these species. So there are lots of options in our toolbox. There are options of turning lights off. There are options of shading lights, of using different wavelengths, of putting in vegetation buffers. But we now also have the opportunity to use flashing lights, to use dimmers, to only have lights on when there are people around, all those sorts of options. So it actually gives me great hope that we will be able to achieve good light management around important habitat. And I guess to that, one of the case studies that a small island built on the coast of Australia, its last name and hotel, it has 9 endemic species. It's a pretty amazing place. It now also has Chevron Australia on the processing facility, huge processing facility, complete with gas flares. It also has one of Australia's largest flatback nesting turtle populations, within 2 kilometres of the LNG plant. But when this approval went through both Western Australian approvals and the Commonwealth approvals, light was considered to be potentially a huge threat. The light from the LNG plant was considered to be a potential threat for the flatback population. And so light was taken into account from the very get-go. So the whole design of the plant considered light and the light impacts on the turtle population. And as a result of that, Chevron Australia developed a long-term turtle management plan to ensure that light didn't have an impact. And to date, it's been in place for 8 years, 10 years. Anyway, it's up and running, it's in operational phase, and to date, light hasn't had a significant impact on the turtles. So we don't see hatchlings running the wrong direction on the beach. We still see turtles coming up to nest on the beach. So it is a success story of how light can be managed. So I guess the take-home message that I want you guys to have from today is that these light guidelines are coming. We intend to have a draft available in early 2019. At this stage, they are for marine turtles, seabirds, and migratory shorebirds. And we are at the stage in the process where we want to consult broadly. So if you guys have input, if you have case studies, Most definitely. Local council is supposed to do that. That would be fabulous. At this stage, they are only guidelines. But as you guys will be aware, even those that are not enshrined in legislation are followed. So if we have some good, strong guidelines that are providing guidance around how to manage these things, then hopefully people will take notice of them and say, okay, we actually need to be thinking about it. Yes, they are in our list of light sources that need to be considered. So
legislation, so will Commonwealth actually legislate that?
So these are not under legislation. These are this is a guidance document under the Commonwealth legislation. But at this stage, it is we have a very long laundry list of things and people that emit light. People don't emit light. Activities that emit light, and cruise liners on it.
In oil rigs.
And oil rigs are
Yeah.
certainly on it, yes.
But that's not my question. It's just to explain to me. So this is a guideline, but you said it's going to be there under the EPBC. So how that works?
So under the EPBC Act, we have guidance documents that provide our assessment officers with a context within which they give advice to the decision maker. So for instance, under the EPBC Act, if you have a significant impact on a matter of environmental significance, then that is what triggers under the Act. And so there are guidance documents around what is a significant impact. So this guidance will be guidance around the threat of light and how it is managed.
One more question. Are street lights on your target list?
They are, yes.
Yeah.